Sometimes the constant of proportionality is not a whole number. The constant of proportionality can also be a decimal or a fraction. When the constant of proportionality involves whole items, like people, it may seem strange to think about the constant of proportionality in terms of a fraction. Instead, you can think of the constant of proportionality as a way to predict outcomes of a situation. Okay, so I don't really want to think about the actual number, the constant. So sometimes it's 2x, so the constant of proportionality is 2, and that might make sense in this situation. However, for our Title IX stuff that we've been working on here in this part, I know that for this, let's see here. I know that for this, if we have to figure out how many girls there would be, I need to take 5/6 times b. And so to answer the question here, or to talk about this, the 5/6 is confusing because we're dealing with girls to boys. And I'm just using that to get to, that's what I have to do to the number of boys to figure out how many girls there are going to be. Okay? Because it's a 5-to-6 ratio. So sometimes understanding the fractional part of here might not make a lot of sense here. It's just a way for me to get, in this case, from the boys to the girls. Okay. The directions here say use your equations. I met with a group that was trying to set up a perfectly correct proportion to get the right answer here, but they're telling me that I need to use the equations that we worked on to figure out my answers. And so I start by writing in the equation. After that, if there are opportunities for 79 boys to participate in athletics, how many opportunities must be available for girls? And so they're telling me the number of boys, 79. And so I need to put in there girls is equal to 5/6 times 79. Now, when I take a fraction times a number, I can write the number as a fraction by putting it over 1. Then 5 times 79 is going to be 395. 6 times 1 is going to be 6. A fraction is a division is a fraction. So 395 sixths is the same as taking 395 and dividing it by 6. If I do that, it will go in 65 with a remainder of 5 out of 6 times. Okay? Now, it doesn't make sense for there to be 65 and 5/6 girls. Okay? So G equals 65 and 5/6. And so that's saying that they have to have at least that many. But I can't have that many girls. And so what makes sense in this question is that there should be 66 girls given opportunities to participate in athletics so that it follows Act 9 and would be proportional to the boys. Okay? And so that's kind of what they're saying. The fraction here doesn't make sense. And so I need to just think of the problem situation here. I like to read what the thinky guy says. Did you use the constant of proportionality for the girls or for the boys? Does it matter which constant of proportionality you use? For B, if there are opportunities for 119 girls to participate in athletics, how many opportunities must be available for boys? Well, that equation would be boys is equivalent to 6/5 times the girls. So I write the equation because they asked for the equation. Then I substitute with the number that they gave me, 119. I'm multiplying that out, 6 over 5 times 119 over 1. I can write any number as a fraction by putting it over 1. Then 6 times 119 is going to give me 714 over 5. Every fraction is a division. Every division is a fraction. Numerator divided by denominator. My remainder is my numerator. My denominator stays the same. Again, we would have 142 and 4/5 boys, which doesn't make sense. So I would want to make sure that we round it to what makes sense. And it'd be 143 boys to make it so that there were an equivalent, a proportional amount of opportunities for the boys compared to the girls um, at this particular school. Okay. And so these are the equations I came up with on the previous page. And sometimes my constant of proportionality is a whole number. Sometimes it's a fraction, but it's basically telling me in this case how to figure out how many boys I would need to give opportunities to, or how many girls I would need to give athletic opportunities to, according to Act 9. All right. So we're on page 120. Identify the constant of proportionality in each equation and describe its meaning. Okay. So D equals 2 times R, where D represents the diameter of a circle and R represents the radius of a circle. Okay. So the directions say identify the constant of proportionality and describe its meaning. Okay. So the constant of proportionality here the constant of proportionality here is going to be 2. And this means that to get the diameter of a circle, I have to multiply the radius by 2. I like that they used an example that we've done before, and so in that equation there is a constant of proportionality because that is a proportional relationship. Okay. In this one, P equals 3 times S, where P represents the perimeter and S represents the sides of an equilateral triangle. The constant of proportionality is 3 here. And so this is saying to get the perimeter of an equilateral triangle, I have to multiply the side length by 3. Because there are 3 sides to a triangle, and all 3 sides are the same length. Okay? So, notice what I'm doing here. I actually am writing out constant of proportionality. My rationale is this. To get some of these terms all stuck in my head, I'm going to write it out more. And because these problems are the same, I'm kind of parallel my answer. Okay. Also, I'm writing more words on here to help me make sure I'm understanding it. For me to formulate sentences, even if it's something simple, that's to make it so I can fully state what it is. shows that I can actually understand it. All right. And so some of us are just putting a few words here or there, and we can be doing a little bit more to help cement our learning. Okay. For the directions, notice that there are 2 parts in these directions. I'll sometimes go and I'll number them because I've noticed that some of us are missing the multi-part directions and only doing one of the parts. Okay. So these are little things that we have to pay attention to as we're doing our work. Activity 2.4, using the constant of proportionality to solve problems. A chemist must use a solution that is 30% of reagent and 70% of water for an experiment. A solution is a mixture of 2 or more liquids. A reagent is a substance used in a chemical reaction to produce other substances. Define variables for the quantities that are changing in this problem situation. Okay, so let R be the reagent. And usually that is in like milliliters, but it could be in something different. And then the other thing that I see here, and this is a confusing one at first to me, so let W be the amount of water. Okay, so when I define variables, I say what the variable is and I say what it stands for. Say what the variable is, I say what it stands for. Okay. 2. Write an equation for the amount of water needed based on the amount of reagent. Okay. So for me to know how much water I would need, and I have the reagent, I would take the reagent, and the reagent is less, so the water is more. And so I would have it be 7/3 times R equals the amount of water. All right, write an equation for the amount of water needed based on the amount of reagent. Okay, water that is needed is going to be 7/3 times R. I like that. What is the constant of proportionality? The constant of proportionality here is 7/3. Okay. So if I'm thinking about this from the beginning, because 7/3 isn't what you'd expect to see here, but if I'm thinking about this, the input in this instance is the reagent. The output is the water. And so based on that, it would be water is Y over the reagent. And the percentages we got 70% water to 30% reagent. And I can simplify that down by dividing both parts by 10 to 7/3. And so that's how I got that as my constant of proportionality. All right, so activity 2.3, representing proportional relationships with equations. Title IX addresses the number of athletics opportunities provided to each gender, but the actual participation at schools may differ. Also, the same person may participate in multiple sports. At Vista Middle School, 5 out of every 7 girls play sports. The guidance counselor, Miss Shanahan, and the athletics director, Coach Culpepper, are completing reports about the students at Vista Middle School. Consider the information each person knows and use the constant of proportionality to write equations for each situation. And so I'm using this data, this information right here to help with these down here. Okay. So first, our guidance counselor, Miss Shanahan. So I'm doing 5 out of every 7. Miss Shanahan knows the number of girls in the school on a given day, and she needs to be able to calculate the expected number of girls who play sports. So to do that, the constant would be, I would need to take whatever she knew, because she knew the whole population, and that would be 5/7. Okay. The athletics director, Coach Culpepper, knows the number of girls participating in sports during a given season, and she needs to be able to calculate the expected number of total girls in the school. So she'll know the sports people, and so she'll need to multiply that by 7/5 to get all of the girls at the schools. Okay? So we could do a whole bunch of variables, but S, and when I define variables, let S be the number of girls who play sports. And conversely, let G, or some other thing, doesn't matter what variable you pick, be the total number of girls in the school. Okay. So think about it. The guidance counselor would know the whole school, and so I'd multiply it by a fraction that's less than 1, because less than all of the girls play sports. The athletic director knows everyone that plays sports, but that's not all the girls in the school. All the girls in the school is bigger, so I multiply it by a fraction that's greater than 1. And so I almost want to think about what my answers will be here, and that'll help me with choosing, in this case, what the constant of proportionality was. All right. Continuing on. Use the constants of proportionality to write equations to determine the information needed by each person. So now that we have my variables and we have the constants of proportionality going on here, I would be able to say that the guidance counselor would know the whole school, and so she would know G. And to get to what she needs, she would have to take G and multiply it by 5/7. And then that is going to equal the number of girls that play sports. And so when I'm writing down these equations, I'm kind of thinking, I'm making sure that I'm looking at what each of the variables means. I'm also kind of thinking, if I can put it into words, what does it make sense for what I'm looking for? The athletic director, and this is kind of like our last problem too, the athletic director would know how many girls play sports, and that's going to be a smaller number than the whole school, so she'd multiply it by the constant of proportionality, which is 7/5. And then that is going to give her the answer of the total amount of girls in the whole school. All right. If we go and extrapolate this, if we make this so it applies to the graphs and everything like that, typically in a graphing situation, next to the constant of proportionality, that's the k, it'd be k times x equals my y. And just because it's a different situation, it'd still be with k times x equals y. Okay? So I've got my equations now for this situation. In terms of proportionality, Miss Shanahan could state that the number of girls who play sports is proportional to the number of total girls in the school at a constant rate equal to the constant of proportionality. Oh, I need to read that again. So I start reading something and I'm a learner and I realize I'm not understanding it. One of my first steps is to go back and reread it. So I zoned out for a second, so I want to just do that again. In terms of proportionality, Miss Shanahan could state that the number of girls who play sports is proportional to the number of total girls in the school at a constant rate equal to the constant of proportionality. So, could say that the girls that play sports is proportional to the total number of girls at the school at a constant rate equal to this. All right. Write Coach Culpepper's situation using the language of proportionality and include the value for the constant of proportionality. This is similar to what we did here. And so that's why they have this here. I was trying to figure out what this is there for, but it's giving me a hint as to what goes there. Okay? So, Coach Culpepper could state that the total girls in the school is proportional to the number of girls who play sports at a constant rate equal to 7/5. 7 total girls in the school to 5 girls that play sports. Okay? So notice how this is just like what we did here. And the thing that they had is include the value for the constant of proportionality. And so that's what I did at the very end here. Okay? And so the things that they put in between are usually helping me to get where I need to go. Number 5, consider the given equations, where y represents the dependent or output quantity and x represents the independent or input quantity. A. Describe how the first equation represents the constant of proportionality. All right. So when I divide the output y by the input x, that will equal the constant of proportionality, or K. Okay, so that's the first one. So B, explain how the second equation represents proportional relationships. Okay. So the output y to the input x will be equivalent to the constant of proportionality k over 1. Okay. 3. Describe how the first equation was rewritten to create the third equation. Okay. So here, so to go from this one to this one, sorry, to go from the first one to the third one. Okay. So if I multiply both sides of the equation by x over 1, or just x, the first equation will equal the third equation. Explain the meaning of the constant of proportionality k in the third equation. All right. In order to get the output y, I need to multiply the input x by k, or the constant of proportionality. Okay. In my mind, what I think they're doing here is they're getting me to do the following. They're getting me to use x as the input because it always is going to be. They're getting me to, if I'm reading and doing this carefully, they're getting me to use y as the output because it's often referred to as the output. And then third, they're showing how this first equation, this second equation, and this third equation are all equal to one another. And a lot of times we've been starting with this to prove that a relationship is proportional. And then a lot of times I can make it into this third one, which would be the equation for a given situation. Okay. And so by me taking the time to put this into words, that's helping me to think about how they're related to each other. And that's why they're asking these questions right here. Number 3, use your equation from question 2. So from question 2, my equation was water is going to be equal to 7/3 times the reagent. Okay. Use your equation from question 2 to write an equation for the amount of reagent needed based on the amount of water. Okay. And so the reagent needed, if that's the output, would be 7/3. It would be 3/7 times W. Okay. And the reason why, and so this would go to this one, and it's because in all of the earlier examples, when we switched the situation, we used the reciprocal of the constant of proportionality. Okay. So if I look back at our previous ones, we used the girls was equal to 5/6 times the boys, and then the boys was equal to 6/5 times the girls. So whenever we switched it, we would switch the constant so it was the reciprocal. We would flip the numerator and denominator around. Okay. And in question 3, you can say that the amount of reagent varies directly as the amount of water in the solution. Okay. In question 2, you could say that water varies directly as the amount of reagent in the solution, and flip them. Okay. Use your equations to answer each question. If the chemist uses 6 liters of reagent, how many liters of water will she need to make her 30% solution? So the equation I have, use your equations, is going to be 7/3 times R. I write the equation down in my first step. Second step, I substitute for the variable what I know, which is 6. Then when I multiply that out, let me show you what that looks like. 7/3 times 6/1. I could multiply and reduce, but that's a pain, so I'm going to reduce first. 6/3 is the same as 6 divided by 3, which is the same as 2/1. Or they both have a common factor of 3, so I divided them both by 3. 7 times 2 is 14. 1 times 1 is 1. And so I would need 14 liters of water to have a 30% solution. Okay. Oops, sorry. This is 77 milliliters of water. How many milliliters of reagent will she need to make her 30% solution? So in this one, they're giving me the water. So I would use the equation of reagent is equal to 3/7 times the water. Or reagent is equal to 3/7 times 77 milliliters of water. If I do that multiplication problem, I have 3/7 times 77/1. I would want to reduce this first. 77 and 7 have a common factor of 7. So I would reduce that. 7 divided by 7 is 1. 77 divided by 7 is 11. 3 times 11 is 33. 1 times 1 is 1. And so my reagent would be 33. In this case, the label is milliliters of reagent. Okay, so I write down the right equation for the situation. I substitute the variable for what I know. Then I solve the problem to find the missing amount. Number 5, write an equation to show that y is directly proportional to x using the constant of proportionality given. Then solve for the unknown value. Y would be equal to k times x. In this case, I would know that 4 is y. I would know that k is 0.7, and I don't know what x is. When I solve this type of problem, I divide this side by 0.7, because 0.7 divided by 0.7 is just going to be equal to 1, or x, on the left side. If I divide 4 by 0.7, I would get 4 divided by 0.7. When I do this, I have to multiply this by 10, and 4 multiplied by 10 is 40, so this moved over 1, and then this moved over 1. I add the 0 for the empty jump. 7 fits into 45 times. 5 times 7 is 35. 40 minus 35 is going to be 5. So I get 5 and 5/7 is equal to x in this situation. For B, y is equal to the constant of proportionality times x. Now I substitute for what I know. Y is equal to 3/11 times 9. 3/11 times 9, 3/11 times 9 over 1. I can't reduce, so I would get 27 on the top over 11. Numerator divided by denominator, 27 divided by 11 gives me 2. Gives me an answer of y is equal to 2 and 5/11. You should be studying these, especially if you don't know how to divide decimals, especially if you're not sure on one-step equations. You should be studying this when we're trying to multiply fractions. I'm showing you these little skills here that we might not have cemented in our brain, and so you do have to be paying attention to this stuff so you get closer and closer to understanding some of this stuff that we haven't gone over fully yet. Y is equal to the constant of proportionality times x. They don't give me y, but they give me the constant of proportionality, and then they give me x, which is 1 and 1/2. Okay? When I'm multiplying mixed numbers, my whole number I can write as a fraction by putting it over 1. My mixed number, turn it into improper. Whole number times denominator plus numerator is new numerator over the original denominator. Now I can multiply. I look to reduce first. There's no common factors between a numerator and a denominator except for 1. So I multiply. 5 times 3 is 15. 1 times 2 is 2. 15 over 2, fraction is a division is a fraction. 15 divided by 2, y is going to be equal to 7 and 1/2. Last, but certainly not least, y is equal to k times x. Getting that formula, that equation stuck in our head, so we know that is kind of how how we write the equations normally for our proportional relationships. Then y is going to be equal to 1/6 times 3 and 1/3. Gosh, they're making it fun. Now, multiplying fractions, that's a fraction, so it just stays as a fraction. The other one, I turned it into a mixed number, or improper fraction, sorry. Whole number times denominator plus the numerator is the new numerator over the original denominator. Next, numerator times numerator is new numerator. Denominator times denominator is new denominator. Ooh, I could have reduced it first. 10 and 6 have a common factor of 2. So I should divide both of these by 2 over 2, which is a fractional form of 1, which gives me 5/9. So y here is equal to 5/9. All right. Whew. Sorry that took a while, but I'm showing you some decimal skills that we've skipped over. I'm showing you some fraction skills that we haven't covered much of that you need to be knowing. And so I want to make sure I did that the right way. I wanted to show you these the right way as well. Gabe! It's always Gabe. You didn't tell me I was making a huge mistake here. Hopefully you saw it. Hopefully you saw it. It's good to be finding mistakes if you're paying attention in different ways. All right, so I started off right. Y is equal to the constant times x. Then I substituted incorrectly. K is 1/6. Y is 3 1/3 because. So it should be 3 1/3 is equal to 1/6 times x. So 1/6 times something will equal 3 1/3. So to get rid of this, multiplication, the opposite is division. So I would divide this side by 1/6. If I divide the right side by 1/6, I have to divide the other side by 1/6. Now, this is a crazy, horrible, complex fraction that we were introduced to, and I like to keep showing because it does keep on showing up. All right, so this could be considered a division problem. Let me show you how. On this side, 1/6 over 1/6 is going to be equal to 1, so the right side is going to be equal to x. Okay. Now this, going from the beginning, we have 3 1/3. First, I would take that, I would write it as an improper fraction. 3 times 3 is 9. 9 plus 1 is 10. 10 over 3 divided by 1 over 6. Now, I want to make this so I can show you why when I divide fractions, I multiply by the reciprocal. So I want to times both sides by 6 over 1 because I want 1 on the bottom here. I want to get rid of this crazy fraction. And if I multiply this part by 6 over 1, I also have to multiply this part by 6 over 1 to keep everything balanced. Whenever I do the top part of this, I do the same thing to the bottom part when I'm making equivalent ratios. When I do that, I get the problem of 10/3 times 6 over 1 all over 6 over 6. 1 times 6 is 6. 6 times 1 is 6. 6 over 6, which is equal to 1. So I can rewrite it again as 10/3 times 6 over 1 all over 1. Whatever's all over 1 is whatever's on top. So we have 10/3 times 6 over 1. If I reduce this first, I would be happier. There's a 6 on top, a 3 on the bottom. They have a common factor of 3. 6 divided by 3 is 2. 3 divided by 3 is 1. And then we get 10 times 2 is 20. 1 times 1 is 1. And 20 over 1 is the same as 20, which is what x should have equaled in that instance. I apologize for my horrible, sad substituting error. But I always want to look for where I'm making mistakes and try to catch them and fix them once I see that I'm off on something. Thank you, answer key.